So Brian let me know he probably can't make it today, but Dean should be joining us.
Awesome. Yeah.
Hello. It's nice to see or hear everybody.
Hey, Philip. Nice to hear you too.
I can confidently say that we can do a working group last call. I just did an implementation of this in 5 minutes, so good from my point of view.
The best thing is you don't have to justify it. Just trust me.
Yeah.
It's very easy.
Yep.
I'm
And
gonna
that's
start.
exactly why we got to talk about it. We'll get into that.
Should I start working on the Shepherd write-up then, Philip?
I'm sorry, Rifat, can you repeat that?
Should I start working on the Shepherd write-up?
Sure, I'll send you the 5-line implementation.
Hey, Deb. Thanks for joining.
Hi, Rafat.
Hey, Mike.
So no problem. I happened to go down the errata rabbit hole, and so I'm just finishing rejecting or verifying a bunch of errata. So I'll be with you shortly.
How virtuous of you.
Well, there's a long story behind this, but I won't bore you with it. But errata verification needs to be updated.
That's why you earn all the big bucks, Deb.
Exactly.
Okay, let us give people 2 more minutes and then we'll get going. So hopefully we see more people joining. So 2 more minutes.
And actually, the one I'm doing right now is an OAUTH errata.
Which one is it? I mean, the for which O of RC?
We can't hear you.
Sorry, it was Jose 7515.
Then it's probably not important.
Well, I'm going to reject it. So
Okay, we're 5 minutes past, so let's get going. Okay, welcome everyone. This is an interim for the OAUTH work group to talk about a deferred key binding, or as Justin likes to call it, trust me, bro. So, come on, there you go. The note well applies here. So this governs everything that we do at IETF. So if you're not familiar with this, please get familiar with that. Just a quick reminder, we have the IETF conference coming soon. So we have 2 sessions for OAUTH work group. The first one is Thursday morning, and the second one is on Friday. That would be Brian's best day. His favorite day is Friday typically. So we have Friday, and it will be the last session too. So it's going to be fun. So that's all on my side. Any comments, questions? If not, I will hand it to Justin to let him drive from here.
All right, I requested slides. So whenever I can get those. There we go. All right, everybody. Only a handful of slides here today so that we can make sure that we're all on the same page. Largely, we wanted this to be a discussion and to basically give us a bit more time and bandwidth than we'd be able to do during the Madrid meeting. So as a bit of a reminder, this is stuff that's started during conversations at the OAuth security workshop, where a handful of us noticed that we were seeing this, seeing a similar pattern showing up in a bunch of different applications and OAuth extensions. We call in the spec, we called it deferred token binding, and I will say I use the term spec here very, very lightly. It's a very, very drafty draft that's just meant to sketch down some ideas, but it is there and can be read. The whole idea for this is that it's about binding a token to a key without presenting the proof of that key at the time of binding. You defer the presentation of the key to a later point of the process where the token is actually presented, often by a different party. So what are we even talking about here? There's a lot of proof of possession mechanisms. The 2 big ones that we have defined for OAuth are, of course, DPoP and MTLS. HTTP message signatures is a newer spec. There's been an OAuth binding that I proposed a bit ago, and that's been profiled in some other spaces. But regardless, in all of these cases, it's assumed that the party that is requesting the token is the same as the party that is presenting the token. And this party, the single party, can always prove possession of the key that gets bound to that token. So we do that using the CNF claim that 7800 defined, and 9499 and 8705 make use of to say this is the key that's associated with the token when you go to actually validate it as a non-bearer token at the RS. So basically the way that the process looks is that you present the key to the token issuer, and then you get back a key, or you get back a token that is bound to that key. Oh yes, 9499. By the way, since Brian couldn't make it, all of the errors in the slides are Brian's fault, and any action items are going to be Brian's.
It's recorded. Just FYI, it's recorded,
Yep.
right?
Yes. Yeah, no, we already warned him. Okay, so the way that proof of possession generally works, in OAuth and in a lot of other places, is a party requests a token, and you get back, along with presentation of a key, and you get back a token that's tied to that key, and then you use that same key to present the token to the token recipient, the resource server in OAuth. Now, this makes a lot of sense as a security posture because we want to avoid things like this. We want to avoid an attacker posing as an authorization server and saying, hey, no, really, I'm a client. Give me a token for this key, and trust me, this is going to be totally fine. And then turning around and saying to an unwitting client, trust me, I'm a real authorization server, and here's a real key that you can use, even though Sneaky AS has been sitting in the middle and manipulating the process the whole time. This is bad. It's worse than an anti-pattern, except that we actually see this in a lot of places. For example, in the current working group draft, OAuth identity and authorization chaining across domains. We know that there are needs in some environments to bind access tokens in ways that don't fit the sort of traditional single domain OAuth security model. So you need to be able to say, like, hey, I need a token with these properties. One of those properties is it is tied to this key. I don't have the key right now, or I can't present it to you in a way that you can verify, but I'm going to need to be able to use it there. Right, and this is the way that that works in that spec. I'm not going to go into that diagram because this is a much more colorful diagram of roughly the same thing. The basic idea in that we're looking at is really not dissimilar from that attacker model that we saw in the previous slide, and that's that we have a client saying, I want a token bound to key number 2, the blue key, but I'm going to provide proof for key number 1, the green key. And the authorization server has to make the decision of when and how to allow that. Again, like I said, structurally, this isn't that dissimilar from the attacker model, except that if I swap the labels on things here, there are a lot of use cases, as it turns out, where this really starts to make sense. And we keep seeing these things popping up. So for example, you have a spiffy agent that is going and getting tokens issued in order to hand them to a workload so that the workload can actually use those tokens at runtime. We'd like those tokens to be bound to the workload's keys, but the agent is also issuing the keys at the same time. So it's not the agent that's getting the token for itself. We want to be able to prove that the agent is the agent and not the workload. But we only want the token to be able to be used by that particular workload at the end of the day. So this is one case that's more whimsy adjacent, but this is really, we keep seeing these patterns in a bunch of different places. So with backend for front end and similar patterns, you have the client split into multiple pieces, and some of those pieces have access to different parts of keying material, different parts of the requests that they can handle, and things like that. Transaction tokens are a particularly interesting application of something like this because you've got a gateway that's going and getting a token, and then that token needs to be carried by a whole chain of items as it goes throughout the system. It'd be really good to have that tied tightly into the key presentation mechanisms and not just be a bearer token that gets carried along through the process and have that cryptographically bound. And then, of course, there is when we go across a trust domain boundary, and this is a lot closer to the cross domain identity draft that's floating around, where we basically are saying, like, hey, we've done all of this work in this one domain, and now we need to cross over to the outside. And with the proof of all of this, I need to get something that's bound to a particular key. Without being able to prove that I actually have public key 1 or 2, but that I've actually gotten to this point because they were able to call me. And there's a lot of subtleties that come into this. So that's basically where we're coming from. And the question that we wanted to talk about today and really dig in with the working group is, what do we do about that? So our first option is, of course, to ignore this. We just call it bad practice, say that it looks a lot like an attacker model, and we hope people stop doing it. Second thing we can do is potentially do an informational or BCP style doc where we document the patterns and sort of where they make sense and what the restrictions are around that. And that would help us as a working group and as a community put up guardrails around potential misuses of this pattern. Because, for example, one of the things that the spiffy-based pattern, what makes that actually work is that the identifiers for the keys are strongly associated with the workloads at runtime because of the nature of the underlying trust fabric. There was also some work that was presented to the OAuth working group over the last few years, and it was presented in a couple of different security spaces in sort of the IoT space, where you have highly trusted key distribution mechanisms that allow you to do this kind of thing and say, hey, just do it to this key, and you can validate that key is real and exists, separate from being able to prove possession of that particular key, right? Because you have something that lets you trust the distribution mechanism. So we could write something about that. We could go further and say, let's add parameters to the OAuth protocol that formalize a way to ask for a key like this. And that's what the draft that I threw together in a handful of minutes in Iceland does. It creates a new parameter and it says, this is the key that I actually want the resulting token bound to, using DPOP or MTLS or HTTP-SIG or really any other kind of POP mechanism. Instead of using my keys, use this key that I'm identifying. And if we go in this direction, this raises a very interesting question of, could we potentially have some type of transitive proof? So not only am I saying this, use this key, I can give you something that proves that that the holder of that key said that I'm allowed to ask for it on their behalf. There's a lot of this on behalf of semantics that's being floated around in the world right now, especially with all of like the MCP proxying and all of that crazy stuff that's going on. This might be something that we want to really sink our teeth into as a working group. And then finally, if you have a token that's bound like this, how do we represent that? Is it something that's part of the confirmation claim? Is it separate from it? Are they tied together? What does this look like? Because do we want to treat tokens like this differently from traditionally sort of single party key bound tokens? We might. I don't actually know. So that is all I have for slides, and these are the questions that we have to the working group. This is the space that we see, and where do we want to go with that? And I talked a lot, so Dean, feel free to jump in and tell me where I got things wrong.
I think the only thing you got wrong, Justin, is that it took you a handful of minutes to create the draft. I think it was probably more like 60 seconds, but thank you for the discussion.
I will have you know, it took me a couple of minutes to download Martin's templates and get that running. So it was a few minutes.
Fair enough. So continuing on the theme that Justin started here, when I look at this slide about what we can do about it, I think ignoring it is to everyone's peril at this point if we ignore this problem and just keep kicking this can down the road. I'm also less excited about an informational or a BCP doc because, yes, we can put up some guardrails, but I'm not sure that's going to result in the kind of outcome that we all seek, which is better interoperable security. So my bias would be to a protocol spec or a token spec. But as Justin said, we really want to hear from the assembled community to understand what should we do, or in some cases, what shouldn't we do, and then figure out how we move this forward, because this work not only impacts the OAuth working group, it pretty clearly will impact the Whimsy working group as well, and the work that's happening over there in workload identities. So I think there's perhaps a question of venue that's maybe a less important question, but first we need to figure out what are we going to do, and I think that's where we sort of open the floor to discussion.
Justin, yeah.
Yes.
I was wondering about what what assumptions you make about the private key and the storage of it. In many cases, the assumption is that private key never leaves the device, and it basically all you get is sort of like the request for the token plus the proof that you possess the private key. But in the PKI world, there's also a model where the server generates the public key and the corresponding private key, and then pushes that to the end entity. And I was wondering whether this looks a little bit like that, or because you didn't say much about like how the private key is distributed or created, stored, and so on.
Yeah, I think that that is one viable mechanism. And so if you look at sort of the spiffy flavored use case, you get something that looks a lot like that. The server generates the key pair and hands it to the workload on startup, and along with that key pair, though, it also gets the token that's tied into that. That is one way to deploy it. It's far from the only way that people are deploying this pattern, but I do think that that is one valid way.
Yeah, I would actually extend that to say that 7800 actually documents that mechanism as one of the potential mechanisms for key distribution. I'm not sure that we need to get into how and where the keys are generated and stored so much as the presentation semantics to ensure that it is understood who the holder of the key is and that they can prove that they hold that key when they present the token. That may be up for debate. I very well could be wrong on that, but I'm not sure that's the problem that needs to be solved here. But it probably does get documented as a pattern for the key generation and storage.
I think that overall, I agree with Dean. I will say that I think that there is probably some implementation considerations and security considerations around key storage. The fundamental assumption, though, is that the whatever entity is requesting the token doesn't have access to the private key and cannot create its own proof from that key. That is the underlying assumption of the structure.
Yeah, if I may add, Aaron, because he's next in the queue, the additional requirement then comes into the picture that then you need to specify a way to transmit and protect the private key when it's sent to the party that actually is supposed to be using it. That's the additional requirement, at least in the PKI world, because there's like if you look at the BKCS 10 for the certificate signing request and the BKCS 5 for the certificate, I think it's 5, I'm not sure anymore. And then there's like a separate spec that describes the way for encrypting and encoding the private key. That may be a specification implications out of that architectural difference, but BKCS 7 it is, thanks to always mix up the numbers.
Yeah, I think that is relevant to the choices that you make with this pattern, but it's I do think it's out of scope for at least what we were trying to target here. Because I think that you get common patterns with a few different types of key management systems, key distribution being a trusted key distribution being one version of that. Right. I think Aaron was next in the queue.
Yep.
Yeah. I just want to say I don't think there's any point in specifying making requirements of like how these keys are stored. That seems out of scope. But the point that I am understanding from here is that you also don't want to require, like in this picture, for example, that the Spiffy agent creates the private key that's sent to the workload. Like the point is that it's able to leverage the key that already exists that it does not and cannot ever have access to. So so I would not make any requirements on how the keys are stored, and then you can do it either way, frankly, if you want it. Cool. Okay, I just want to make sure I understood that right.
Yeah, that was the model that I had in mind. Let me go to the more generic version of
Well,
it.
so the actual thing
Yeah.
I wanted to
Oh, okay.
mention was this seems to have parallels to another problem that I have. I have a draft on Data Tracker from like 2 years ago, and I don't think I've ever presented it at an IETF meeting, but I did talk about it with some people at IIW about when there are two chained OAuth flows. So
Yep. I
client
remember this
to
one.
AS to another AS,
Mhm.
and I remember we had briefly discussed the idea of how do these get depop bound in the context of that, and it seems like this would also work. Whatever solution we come up with for this would also work in that case, which I think would be very useful because that draft has recently come across my radar again. In fact, this morning with a call on a call with some people from the U.S. financial space who are wanting to solve that problem.
Yeah, I think there are also implications, Aaron, on the client on behalf of another client chaining as well, which I think is a separate one from the one you're talking about. Or is that the
Yes.
same one?
No, it's separate. It's different.
It's separate. Yeah. So this kind of pattern keeps coming up, and it's all about to me, it's all about how do we create a mechanism where we can, do this type of token request in a way that's not just leaving it absolutely wide open for the for the fake AS to fool
Yeah.
everybody.
So my preference here would be to actually go pretty far with the definition of it, including possibly even describing a way to pass that in a provable way, not just the
Mhm.
trust me way.
Yeah,
So
and
actually give you that full chain of custody.
yeah, and so that was the going back to the list. That's kind of the protocol spec option. Is there a way to create a transitive proof that we can cryptographically verify that this kind of went through? Because that's something that's also needed in the workload space in some cases. It's, so the cross-domain workload is, it's not just that I'm asking, it's that I'm asking on behalf of a workload function that got all the way to me by going through the right chain of processes, and I can show you that state somehow. So it's there's a lot of things that we're feeling very, very similar to each other, and that's why we thought that this was something that the working group really ought to start looking into.
I would also add, as we get deeper into thinking about delegated authorization beyond just the single party delegated authorization that we have today in OAuth, but delegated authorization like parent working on behalf of a child or on behalf of an incapacitated loved one, that this plays into those kinds of actions as well at some point. So we, it's great that we're thinking about OAuth and Whimsy, but we should be, trying to, and I think this maybe points us toward more of a protocol than a token spec, expanding that view out and really figuring out that transitive trust that Justin was talking about, I think is potentially the right path forward. Aaron, I'm not familiar with the draft that you referenced. Do you mind dropping a link to it in the chat, please?
Yep, I will do that. It is old and expired, but it's called Client and Device Metadata for Nested Flows.
Yeah, if you
Okay.
post it into the chat window, I can include it into the meeting minutes. Oh, thanks a lot. Justin, a question, because you mentioned it, and transitive. You said transitive proof. Could you explain a little bit more what you mean by that? What is a transitive proof here in your?
This is a term that's going to get all of the cryptographers on the call mad. So, sorry, Deb and others. But conceptually, the idea is that if I can hand something to Dean, that Dean can hand to someone else, that functionally says, Justin says that Dean says that Justin says this. Right. So that's it has to tie back to itself. So it's something that I can hand Dean, so that when Dean goes and hands that to Aaron, I'll pick on him because he spoke up. So that when Dean goes and hands it to Aaron, not only does Aaron know that it's coming from Dean, but Aaron knows that I am the one who told Dean to go do something. And whether that's something that we, do some, nested signature type of thing, or there's identifiers that we lean on or something like that, I don't know. I think that there's a bunch of different crazy ways that we could do this from an engineering standpoint. But what the right structure is for that, I honestly don't have a really good idea. Functionally, though, it's about the party that ultimately gets the token being able to provide something to let somebody else fetch the token for them.
Okay, that's there is a lot of prior work on this.
Yes,
like in space of transitive trust, like if you look at the voice over IP protocols, for example, that's what they did initially for their identity management.
Yeah, it's part of the SIP handshake, if I recall, right?
Right. It's
yeah.
Like
BSO. It's been about 20 years since I've done SIP, but yeah.
Yeah, but it's okay.
Yeah, I think that there's a lot that we can learn from. Absolutely.
Thanks for the explanation.
Mm-hmm.
Okay. Anybody else? Any other thoughts? Yeah, Deb. Go ahead.
Yeah, I tried not to do this. Can you go back to your picture with the workload and the?
Yeah, sure. Here we go.
So is there a reason why the path has to be from the SPIFFE agent to the AS, or could you have the path be from the workload to the AS? So could you have the workload sign the AS, the SPIFFE agent thing saying, yeah, I know this is a good guy, go give me a token, and then have it guy go to the AS? Like, I think you can play with directions of things, right?
Well, if you could do that, then that's just regular OAuth, and we don't need anything new. It would be. You could get an assertion, do the token trade, and some people are doing that. In the workload space in particular, there's a lot of there's a big push to have the workloads be very restricted in the functions that they have. So adding a whole token fetching and management stack to the workload is a lot for something that spins up, lives for a few seconds, and then goes away forever. In the SPIFFE world specifically, and a lot of Whimsy and Whimsy adjacent stuff, these workloads, when they get stood up, they get handed all of their identity, and they may have a key from some HSM or something like that they get handed access to when they spin up, but they don't. They're not really expected to go and fetch their own credentials in order to go to the next step. They're expected to basically start the world without knowing anything about themselves, but being able to just go and call the next step of the process. And that's for simplification purposes, that's for size purposes, that's for efficiency purposes, all of that.
Okay, so you should specify all of that, right?
Yes. Yep.
But I think Deb mentioned a really important point, because there's an architectural issue around many of the scenarios, or some assumptions, and maybe it's also a good idea to revisit some of those assumptions, whether those they were made at a time when some of the security requirements weren't that important, and now we are trying to retrofit some of those things. I don't think like the workload, like if you look at the not the plain container environment, but more, for example, a confidential container environment, there you have all that stuff starting straight out of the workload, not from an agent, because the agent is the one you want to protect also against.
Yeah, there are ways to deploy it where you don't have this pattern. Absolutely. But that's that's not the space that we're looking at. So what I'm hearing from you, Hannes, is basically option 0. Tell people don't do it that way.
No, I think we need to articulate the assumptions we are making quite clearly.
Oh, absolutely.
Yeah.
Oh, yeah, absolutely. This is something that, and this is one of the reasons that I actually wanted to specifically bring this conversation into the OAuth working group, is that I think that people that are deploying stuff that kind of works in this way are making a whole bunch of assumptions that they're not necessarily writing down and fully considering. And so, at the very least, I think having those assumptions written down that, okay, if you're going to do something like this, then yeah, you need to be able to answer the following questions about your setup. At the very, very, very least, I think that that would be an invaluable resource to the community. I am with Dean, though, that I think that we can do a lot to go further up the stack.
Yeah, that makes sense.
Aaron?
I just wanted to give another example scenario. Can you go back to the diagram that was not the workload version of the diagram?
Okay. Hang on. There we go. All the thumbnails look the same.
Yeah. So the other reason that the client 2 in this diagram may not be able to talk to the AS, 2 scenarios. One is that the AS is actually not on the public internet, and it's only accessible from client 1, but client 2 is on the public internet and can't talk to it. That scenario is called out in the identity chaining draft. It was one of the use cases for that. And then the other version is client 2 does not have internet access, and it is working on a network that can talk to client 1, but client 1 does have internet access. So both scenarios where one of the roles doesn't have internet access.
Yeah, and that first scenario fits with a lot of the kind of, gateway into internal access type of stuff that we've seen, where client 1 is either the gateway or is really close to the gateway, so it has access to the AS, but client 2 does not. And the RS also has access to the AS, or its keys or whatever it needs to validate things. But client 2 cannot actually make that call in, because client 2 is not registered and trusted to make that call. Client 1 in this case is trusted. It is a trusted entity. It can ask for tokens. But the gap here is that client 1 isn't asking for tokens for itself. And that's where the assumptions of the existing OAuth architecture kind of fall over.
So I agree that it's a good idea to list out these different scenarios as like, here's why you might find yourself needing this.
And that might very well just be the first place to start in the next iteration of the Trust Me Broad draft.
So, yeah, somebody joined the line here. I don't know.
So just one question, like how is the client 2
Sorry.
interacting with client
Who is this?
1?
Maybe introduce
This is
yourself.
Sudarshan. This is Sudarshan.
Okay.
I was just wondering that how is client 2 interacting with client 1 in this scenario, and what is the proof that client 2 is given to client 1, and then the client and then asking client 1 to interact with AS1?
That's a great question. I think that there are a lot of different ways that can be sliced. In the workload scenario, it's the workload spins up in a context, and the Spiffy agent and Spiffy server are the overlords of that context. So they just dictate what the workload gets. In the more generic case, so like the client talking to a gateway or something like that, you could be using attestations, you could be using other bits of context to tie these pieces together, so that client 1 and client 2 know of each other in some way, in some configured way. What exactly that looks like, from what I've seen of this pattern showing up in the wild, it tends to vary a lot. I don't know what the common patterns really are yet, but calling out those common patterns is one of the things that I think that we can really do here.
Okay. Yasin?
Hi everyone, Yasin Burshish here. First time I participate in an IETF working group. I work at a bank in Canada, Desjardins, and in the cryptographic space. So one of the things that I was exploring when writing a draft I'm working on for Whimsy was self-contained proof. So in the scenario where you're not able to talk to the AS, what I was considering using would be the X5C header. You have the certificate chain with the public key, and you sign the JOT. Therefore, you're able to say, hey, it's supposed to have this key in here, even though it doesn't need to communicate to the AS initially. I'm wondering what you guys think of that.
Yeah, that's kind of the nested transitive proof process that's in line with the PKCS7 approach, right? So you're basically signing something with your key identifier in it to hand to somebody else that they can then pass to the AS in that context. So yeah, that could very well be a mechanism in cases where you have a PKI that you can lean on to answer those questions. And you're doing Jose. So yeah.
But to also follow up on what Deb mentioned earlier, and maybe this is out of scope, or it's not the right use case for this, but if you were to treat something like the AS as a spiffy workload itself, and while the identity itself is ephemeral, the workload itself stays up. Could you theoretically use the X5C header for something like the trust domain, like the pseudo PKI that Spiffy Inspire does?
I mean, I don't see why you couldn't solve it with that.
Yeah, because
I'm back of a napkin. I don't think that that's a universal solution, but I think that that's a way to solve it.
I see.
Because not everything's going to be doing Jose, not everything's going to be doing PKI, not everything's going to be doing, static established trust domains.
Right.
Because as dynamic as the identities and keys are in Spiffy, the trust domains are not. And that's kind of the purpose. They're contextual and assigned. So yeah, I think that goes, to me at least, that goes into what Hannes was saying before about being very explicit about what the assumptions are behind any of these use cases, and what I think it was Aaron was mentioning of basically, writing down the scenarios and use cases and what the parameters for those are, should you find yourself in this space.
And I think, Justin, it goes beyond that. And if you'll go to, I think it was your last slide in the deck, where we talked about protocol spec versus token spec, what we may end up with, and this is looking forward quite a bit, and I don't know that we'll get here, is maybe we'll end up with a protocol, and then we have to profile that for different kinds of presentation in different kinds of tokens. I don't know. I'm just kind of, again, thinking forward, but at least we have to understand the use cases first, and the different patterns that we see, so that we can then begin to build from there and figure out, is there sort of a universal pattern that we can derive, and then we can apply that in different types of tokens, right?
Yeah. So just to follow up on that, Dean, like, if that is the case, which seems reasonable, it makes sense to me. Does it make sense to start with an informational BCP type of a draft, and then maybe kind of take it to the next level if the work group kind of sees the problem and the need for it, whatever? Like, is that an option that you think reasonable?
I think, is it a reasonable option? Yes. Is it the option I would choose? Probably not. And the only reason I say that is because if we work instead on a protocol spec and start that with the various use cases, it may get us to the endpoint faster. It may get us to the same outcome, but do so faster because we haven't taken the step to do an informational and then do a protocol, etc. But I'm open to feedback. And now that Brian Campbell's here, it's all of his problems, so he can deal with it.
Yeah, Brian's got this.
Yeah,
Go ahead.
Go ahead, Justin.
I just wanted to follow up to that if I could. I think that it's a starting that spec that gathers the use cases and the sort of the guardrails and parameters is probably a good place to start, but I would not want to see us make finishing that a dependency on doing anything else. In my experience, starting with the abstract and then adding the concrete later only ends up pointing at the holes in the abstractions. It doesn't actually give you a good framework.
Yeah,
I'll point to the OAuth POP framework and others with for that.
Yeah, I wasn't suggesting that you write a BCP and publish it and then work on the draft
Got it. Okay.
on the spec. It's just start from there,
Mm.
and then we convince ourselves, hey, this needs to be more than just a BCP. Then elevated that draft into a protocol draft, right?
Mm-hmm. Yeah, I would be really interested to see what other protocol and sort of data format type of solutions people have to this, because what I sketched out is probably terrible, but would work, and in the right circumstances, because it's dead simple. But there are absolutely better ways out there to do this that I would like to see us as a community both shake out ourselves, but also pull from people that are building this already. Oh, and we seem to have scared Brian away, unfortunately.
Okay, well, he's back now. Okay, so people like on people that attend here. So what do you think? Like, where should we go? Should we start directly with option 2? What do people think here?
Do you want to do a poll, Rafat?
We could.
There's not a lot of people.
Exactly. Yep. That's the reason I'm hesitant.
Not a lot of people speaking up either.
So Rafat, perhaps an option from a process perspective, and we've got both chairs in the AD here, so this is a good time to ask this. Perhaps an option would be to sort of queue something up for the group-wide meeting in Madrid, to make a next steps decision in Madrid after discussion on the list, after people get a chance to review this conversation and the notes and stuff like that.
Yeah. So
but without a deep conversation about this topic specifically in Madrid necessarily.
Okay, got it. Yeah, like right. we have a packed agenda already.
Exactly, yeah.
So I'm gonna squeeze it. I'm trying to squeeze it into maybe the Friday, because Brian likes Fridays. So
okay.
So maybe we can squeeze, I don't know, hopefully 10 minutes, give you 10 minutes there, and try to find a way to kind of get the feeling of the room, but don't go into that details. Just let high level and then get the feeling. Okay.
Yep. Read the draft. Tell people, go read the notes, read the draft. This is the option. Yeah. And Dean and I and Brian can probably put something together on the list, kind of push this a little bit, push the discussion a little bit further.
Yeah, that would be great too. Yeah, awesome. Okay.
Nope, that works for me. I will personally not be able to attend Madrid in person, but I should be able to connect remotely.
Okay, then Brian should be presenting on Friday in the last session.
Yeah, I also made the decision yesterday not to attend in person, but I will be attending the OAuth meetings remotely. So it's all on Brian.
Sorry, Brian.
Not sorry at all.
Okay, awesome.
All right.
Brian is quiet. He doesn't want to speak. He's shy today. So, okay. Anything else? Okay. Justin, Dean, great presentation. Thank you, guys. And see you in Madrid, guys. Or, sorry.
Well,
Like,
we'll see you. We will see you guys in Madrid from where
Yeah.
we are.
Yeah, you'll see me right here in this very same place.
there you
Yeah.
go.
I'm
Sounds
actually
good.
going to be on my way to a train station, but we'll figure that out then.
Yeah. Okay. Sounds good.
All right.
All right.
Okay. Thank you all. Bye.
Thanks
Thanks
a lot.
Bye.
Bye.